Okay, so today we're going to take a deep dive into the amazing story of Ingenuity, the little Mars helicopter that could.
Yeah, it really captured the world's imagination, didn't it?
Absolutely. I mean, who would thought we'd be flying helicopters on Mars, right? And the way it just kept going and going, way beyond its initial mission.
It's a testament to the ingenuity and resilience of the team behind it, for sure.
Totally.
Yeah.
So let's rewind a bit. We're talking about a mission initially planned for just 30 days on Mars. A quick proof of concept show that it's possible to fly in that thin Martian atmosphere.
Yeah, just a tech demo, really. But it turned into an epic 427-day adventure, way beyond anyone's expectations.
427 days. And at the heart of it all was this tiny 680-gram helicopter. It's mind-blowing how light it had to be to even get off the ground on Mars.
Right. That atmosphere is barely there, just 1% as dense as Earth's. It's like trying to fly in a near vacuum.
Which makes the fact that they built this thing using off-the-shelf parts even more impressive. I mean, we're talking smartphone components, batteries similar to what you'd find in a cordless drill.
It really speaks volumes about the resourcefulness of the team. They weren't given a blank check to build some custom, super expensive piece of aerospace tech. They had to be creative.
And creative they were. So picture this. Mars, hundreds of millions of kilometers away. The Martian winter is setting in. Temperatures plummeting to 80 to 85 degrees Celsius at night. Dust storms are kicking up, blocking out the already weak sunlight.
Pretty unforgiving environment for a delicate little piece of tech, wouldn't you say?
For sure. And then, after 427 days of exceeding everyone's expectations, silence. Back on Earth at JPL, the team is trying to contact Ingenuity, but they're getting nothing. All signs point to it being lost.
Yeah, it's been heartbreaking, especially after all they'd accomplished.
Right. And to think, even NASA initially had doubts about the mission's scientific value. One of the scientists on the Perseverance rover mission, Kenneth Farley, said, spending 30 days working on a technology demonstration does not further the goals directly from the science point of view.
I can see their point, I guess. With limited time and resources on Mars, every activity has to be carefully weighed against the primary scientific objectives.
But that just makes this story even more incredible, right? They had an $80 million budget. That's tiny compared to typical Mars missions or even a Hollywood movie like The Martian. They were a scrappy team trying to prove what many considered a crazy concept.
And they did it. Landed on Mars with Perseverance on Sol 0, February 18th, 2021. A Sol, by the way, is a Martian day, slightly longer than an Earth day. Then cut the umbilical cord, and little Ingenuity was on its own.
And the primary mission was simply to prove that flight on Mars was possible. I mean, that was the big question mark. Could something fly in that thin air?
It had never been done before. It required some serious engineering ingenuity. The ultralight design, those rotor blades spinning at over 2,400 RPM.
Were there concerns about using those off-the-shelf components in such an extreme environment? I mean, Mars isn't exactly known for being gentle on electronics.
Oh, absolutely. The temperature swings, the radiation, it was a calculated risk. But the potential benefits in terms of cost and development time outweighed the concerns for this technology demonstrator.
And then, on Sol 58, just 2 months after landing, history was made. 120 years after the Wright brothers first flew on Earth, Ingenuity took to the Martian skies, humanity's first powered, controlled flight on another planet.
An incredible moment, wasn't it? It opened up a whole new dimension for exploring other worlds. We weren't confined to the surface anymore.
And that was supposed to be it, mission accomplished. But its success led to a change in plans. NASA extended the mission, tasked Ingenuity with helping Perseverance search for evidence of ancient life by scouting ahead, going into risky areas that the rover couldn't safely reach.
So this little tech demo suddenly became an essential part of the science mission. Talk about exceeding expectations.
But flying on Mars isn't like flying a drone here on Earth. You can't just use a joystick. The communication delay is massive, at least 6 minutes round trip, even when Mars is closest to Earth. And Ingenuity's flights were often less than 2 minutes. Real-time control was impossible.
Yeah, so it had to fly autonomously. Basically, it was pre-programmed with a flight plan, and then it was on its own.
And how did it navigate? I mean, there's no GPS on Mars, right?
No GPS. Instead, it used a downward-facing black and white camera. It took 30 images every second, analyzing them to track its movement relative to the ground, like an optical mouse on a mouse pad.
Clever. But this system wasn't foolproof. On Flight 6, the first time it ventured away from its initial test area, things got a bit hairy. A color image from a separate camera arrived at almost the same time as a black and white navigation image.
And that messed things up. You see, the system wasn't designed to handle that. It dropped a crucial black and white frame, throwing everything out of sync.
So every subsequent image was out of sync, and Ingenuity thought it was lagging behind its actual position. It started overcompensating, leading to wild wobbling.
Yeah, it was like a positive feedback loop. Thankfully, the software detected the anomaly and initiated an emergency landing before it crashed.
Close call. But they patched the software and got it back in the air. Then came another Martian challenge, a dust storm.
Ah, yes, the dust storm. Right before Flight 19, they got data indicating a storm was brewing near Jezero crater where they were operating, had to ground Ingenuity and wait it out.
And that storm turned out to be a big one, lasting 6 sols, with wind gusts up to 20 meters per second. Luckily, Ingenuity survived, but the dust itself presented new problems.
Martian dust gets everywhere, and it's a real nuisance. It coated the solar panels, reducing their power output by 18%, and it started clogging the tiny servos that control the rotor blades.
So they had to get creative again. To deal with the reduced power, they adjusted flight durations, made sure they weren't using the heaters too much, and for the jammed servos, they came up with a clever solution, repeatedly wiggling them until the dust had dislodged.
It's amazing how adaptable they had to be, constantly coming up with workarounds for these unexpected challenges, a real lesson in engineering ingenuity.
And we haven't even talked about the extreme temperature swings on Mars. Nighttime temperatures can be incredibly cold, but even during the day, the thin atmosphere means the temperature can fluctuate wildly.
You're right, it puts a lot of stress on the components. Remember, many of Ingenuity's electrical connections were hand-soldered, and those different metals expand and contract at different rates.
And the lithium-ion batteries, if those froze solid, it would be game over.
Exactly. That's why they had the warm box, a thermally controlled enclosure with resistance heaters. It kept the vital components warm during those frigid Martian nights.
But those heaters used a lot of energy, sometimes even more than the flights themselves. And as Mars entered its winter, those nights got even colder, putting even more strain on the batteries.
It was a delicate balance, really. The colder it got, the harder the heaters had to work, drawing more power. If the batteries got too cold, their efficiency would drop, leading to a vicious death spiral.
And then, the morning of May 3rd, 2023, disaster. The team at JPL was expecting the usual data downlink from Ingenuity. Nothing. It was like it had vanished.
That must have been terrifying after all they'd been through, to lose it like that.
Right. They sent pings, tried everything. Silence. The big question was, had they lost their $70 million helicopter to the Martian winter?
But they didn't give up hope. They started digging into the data, trying to figure out what could have happened, and they came up with a theory, the alarm clock hypothesis.
And this was pretty ingenious. You see, Ingenuity was programmed to wake up periodically, listen for commands from Earth. If it didn't receive any, it would go back to sleep. They theorized that the prolonged period of low sunlight had drained the battery completely, causing everything to shut down, including the heaters.
And because the onboard clock relies on a stable power supply, it would have reset itself. So when the sun rose again and the solar panels started charging the battery, Ingenuity would wake up, but at a completely different time than expected.
They calculated a new wake-up time based on the Martian sunrise at Ingenuity's location. It was like setting an alarm clock millions of kilometers away.
And wouldn't you know it, they sent pings around the new time and they got a response. Ingenuity was alive? It had somehow survived being frozen?
It was incredible. But not everything survived the deep freeze. The inclinometer, a sensor that tells Ingenuity its orientation before takeoff, had failed. Without it, any attempt to fly could be disastrous.
That was a major setback. The inclinometer is crucial for a stable and controlled ascent.
But then they had this brilliant idea. Remember, Ingenuity was built with off-the-shelf smartphone components. Modern smartphones have these sophisticated sensor packages called IMUs, inertial measurement units.
They use accelerometers and gyroscopes to track motion, figure out which way the phone is being held. It's what allows for things like step counting and image stabilization.
And Ingenuity just happened to have an IMU of the same type found in a Google Pixel 3. So they reprogrammed the flight control computer to use the data from the IMU as a replacement for the inclinometer.
Talk about thinking outside the box. It was a stroke of genius.
And speaking of those off-the-shelf parts, they turned out to be surprisingly resistant to cosmic rays. You know, Mars doesn't have a thick atmosphere like Earth, so it's bombarded with a lot more radiation.
Cosmic rays can actually cause bit flips in electronics, which can lead to all sorts of problems. There's even a story about bit flips affecting election results here on Earth.
It's mind-blowing how something so fundamental can have such a big impact on technology. You'd think you'd need specialized, radiation-hardened components for space.
You would, and for a long time, that was the thinking. But Ingenuity showed that carefully selected commercial processors and sensors could actually handle the Martian environment pretty well.
It's a game changer for space exploration. Using commercial components opens up so many possibilities in terms of cost and development time. NASA's even looking at qualifying batches of commercial processors for radiation tolerance instead of always building everything from scratch.
It's a much more agile approach, allowing them to adapt to changing technologies much faster.
So with a little ingenuity and a lot of luck, Ingenuity continued its mission through the Martian spring, setting records for speed, distance, and altitude. It even reached a height of 24 meters and a top speed of 10 meters per second.
They kept pushing the limits, flying faster and further. They even started flying higher to overcome some of the limitations of the vision-based navigation system. You see, at higher speeds, the surface features would move too quickly for the camera to track.
That makes sense. By flying higher, they expanded the camera's field of view, making those surface features appear to move more slowly.
Exactly. It allowed the navigation system to keep up.
Then they reached a scientifically fascinating region called Vallis, an ancient river delta within Jezero Crater. But on Flight 71, they hit a snag. Ingenuity's navigation system, which relies on those surface features, started having trouble over the featureless sand dunes.
It was like Flight 6 all over again, but this time there was no easy software fix. Without distinct landmarks, the camera couldn't figure out where it was. It led to an emergency landing, a very hard one.
And despite that hard landing, they thought Ingenuity was okay. They attempted one more flight, Flight 72, just a simple up and down to assess its condition. But on the way back down, the same navigation problems cropped up over the dunes. This time, the landing was fatal.
It was a sad end to an incredible journey. The image from Perseverance showing Ingenuity's broken rotor blades was heartbreaking.
It's been called the first air crash investigation on another planet. What's interesting is that there wasn't a big impact mark at the crash site. You'd think with those rotors spinning so fast it would have dug a crater.
That puzzled everyone at first. But after analyzing the damage, they figured out that it wasn't a direct ground strike that broke the blades. It was the forces generated within the spinning rotors themselves during the landing.
They did some tests here on Earth and demonstrated a concept called precession. Basically, when you apply a force to a spinning object, the effect of that force is felt 90 degrees later in the direction of rotation.
So when Ingenuity landed hard at an angle, it created a twisting force on the blades, and the blades snapped right where the internal reinforcement tapered off, exactly where that force would have been most concentrated.
Amazing how they pieced that together. And thankfully, all that valuable data from Ingenuity's flights, including the crash, is feeding into the design of the next generation Mars helicopter, Chopper.
The Chopper's going to be even more capable. It's got reinforced rotor blades to withstand those landing forces, and instead of 2 rotors, it's got 6.
6 rotors.
Yep.
That's going to give it some serious lifting power. They're saying it'll be able to carry up to 5 kilograms of scientific instruments.
And here's the best part. Chopper will be able to communicate directly with satellites orbiting Mars. It won't need to rely on rovers like Perseverance as communication relays. We're talking about a helicopter that can fly independently, potentially covering over 3 kilometers per sol.
Unbelievable. That opens up a whole new world of possibilities for exploring Mars. And they're even talking about using helicopters as delivery platforms for future rovers.
Yeah, imagine that. No more complex sky cranes, just a helicopter gently lowering a rover onto the surface. It's a game changer.
The future of Martian exploration is looking pretty exciting, and it's all thanks to Ingenuity paving the way. It really has changed the way we think about exploring other worlds. What seemed impossible just a few years ago is now becoming reality.
It's a testament to human ingenuity, that willingness to push the boundaries, to try things that might seem crazy at first, and to think it all started with this tiny little helicopter built with off-the-shelf parts.
And one final detail, just to bring the story full circle. Attached to the underside of Ingenuity was a tiny piece of muslin fabric taken from the wing of the original Wright Flyer, the first successful airplane.
A beautiful symbol, isn't it? Connecting the first flight on Earth to their first flight on another planet.
It really highlights the lineage of human innovation, how each breakthrough builds upon those that came before. But even though its flying days are over, Ingenuity isn't completely done. It's now serving as a stationary weather station for Perseverance, taking pictures and recording temperatures.
Pretty impressive for a helicopter with broken rotor blades. It speaks to the robustness of the design.
Absolutely. So there you have it, the incredible story of Ingenuity, the little Mars helicopter that could. It's a story of pushing the boundaries of what's possible, of overcoming challenges, and of inspiring future generations of explorers and engineers.
It makes you wonder what other seemingly impossible feats are out there just waiting for someone to take that leap of faith and try. What crazy idea in your own field of interest could revolutionize the way things are done? Ingenuity shows that sometimes the most groundbreaking innovations come from the most unexpected places.
So keep dreaming big, keep pushing those boundaries, and who knows, maybe you'll be the one to make the next impossible thing possible. Thanks for joining us on this deep dive.
It was my pleasure.
Until next time.